Hello, in this video we're going to be talking about significant figures. We're going to talk about why they're important. We're going to talk about how to determine them. We're going to talk about some rules that we have to keep in mind when we're doing different operations. And then along the way we're also going to work through some examples. So the first thing, why are they important? Well, significant figures, they tell us how to round, but they also make sure that the answer we get from a math question is not more precise than the number that we started with. So it's basically for precision of numbers. And also, whenever we do significant figures, all the digits are calculated with certainty, plus we add the last digit is just an estimated digit. And what I mean by that, we're going to look through this example. So over here, you have a beaker of water. Now, for certain, you can say that it has 40 milliliters of water. Now, the one estimated digit you're going to, guess based on what you see right here. So you can say it's 40.3, 40.4, whatever the estimated digit is. So that's what I mean when we say that all digits are calculated plus one number that is an estimated digit. So now we're going to talk about how to determine which numbers are significant versus which numbers are not. So in order to do this, we have two rules basically. The first rule is that a number has to be behind a non-zero number. And the second rule is that a number must have a decimal for a zero to be considered. So in the first rule, if we look at this number right here, 0.045, it only has two significant figures because the first two zeros are not significant because they're not behind a non-zero number. So if we want that to happen, if we want them behind a non-zero number, we just put a number in the front and we put a 3. So 30.045, it has 5 significant figures. So for the second one, if we look at this number right here, 50,200, this number only has 3 significant figures because the last two zeros are not significant because it does not have a decimal point. So if we were to put a decimal point, then those last two zeros would be considered significant, and this would have 5 significant figures. So we're going to stop here and look at some examples before we move on. So the first number right here, 2005, it only has 4 significant figures, okay? The second one right here, 25,100, it has 3 significant figures. The last two zeros are not considered significant because there is no decimal point. This one right here, 0.000210, has 3 significant figures. The first four zeros are not significant because there is not a non-zero number in front of it. But the last zero is significant because it's after the 2 and the 1. And this one right here, 1000.0, it has 5 significant figures because all of the zeros matter. Because this number has a decimal point and the zeros are following that 1, which is a non-zero number. That's why all of those matter. So when we look at significant figures, both of the rules that we mentioned earlier has to be true. 1, you have to have zeros behind a non-zero number, and 2, you have to have a decimal point somewhere in the number. So another thing we're going to talk about are exact numbers. So usually significant figures don't apply to exact numbers. So what are exact numbers? Exact numbers are anything that you can count. They're exact. For example, dollars, soccer balls, pizza, all of those things you can count. So significant figures wouldn't apply to those. And exact numbers also come from a predetermined value. So for example, when we do dimensional analysis, our conversion factors are exact numbers. So significant figures wouldn't apply to those as well. So now we're going to talk about how to determine and how to write significant figures. So the first thing we do is first of all, we have to determine how many significant figures we need. And after that, you look directly right to that last digit, and then you round either up or down. So for example, this number right here, it says to round 1.459 to 2 significant figures. So since it says two significant figures, we underline 2 digits because that's all we need. So it's the 1.4. And then you look directly right of that 4, which is a 5. And because it's a 5, you round up, and then your answer is a 1.5. So when it comes to multiplication, division, and addition and subtraction, significant figures has its own set of rules. So when we multiply or divide, our answer must be rounded to the least number of significant figures. So for example, if you have this problem right here, 13.8 times 14.56. When you multiply both of those, you get 200.928. Now, we can go through and determine how many significant figures each number has. So the first one, 13.8, has 3, 14.56 has 4, and the least number of between those two is 3. So then our answer also has to have 3 significant figures only, which is the 200. So then again, we look directly right of that last number, which is a 9. And because it's a 9, we round up to a 201. Now for addition, our answer must be rounded to the least decimal place value. So if you have this problem right here, 18.53 plus 25.672. When you add both of those together, you get 44.202. So for 18.53, it has 2 digits after the decimal point, and 25.672 has 3 digits after the decimal point. So between those two, the least one is 18.53. So our answer as well, it should only have 2 digits after the decimal point, which would be up to 44.20. And then we look directly right of that number, the last significant figure, which is a 2. And because it's a 2, we can just keep it the same, round down. So it would be a 44.20. And that is the end of this video. So in this video, we talked about significant figures. We talked about why they were important. We talked about how to determine significant figures. We also looked at 3 examples. We also reviewed the rules of how to determine significant figures when we have multiplication, division, addition, and subtraction. All right, well, that concludes this video on significant figures. I hope you enjoyed it and have a nice day.